Hello everybody, welcome back to Algebra 2 Unit 2. Today we're going to be talking about the last two sections of our unit, 2C and 2D, which is graphing absolute value equations and graphing absolute value inequalities. Like always, if you need to check problems, just scrub through. These are the notes. But yeah, let's get started. So, when we are talking about graphing absolute value equations and inequalities, we'll be using the same type of form. The only difference is one's going to be an equal sign and the other one's going to be an inequality, like less than, greater than, less than or equal to, or greater than or equal to. So, this form is vertex form. And the vertex form, the general formula for vertex form is f of x is equal to a times the absolute value of x minus h plus k. So our vertex form here is our general formula for our absolute value, where h and k is the vertex of my graph and a is the slope of the right side. So let's look at an example. So there are going to be two ways that we're going to ask you to solve or to graph a absolute value function. The first way is by using a table of values, and this way is probably the main way that you should probably do graphing absolute value functions. The reason is because we're going to be using these table of value functions for our next units in quadratics and beyond. So it's good to get your practice in now and try to do most of your problems through table of values. We'll be talking about the second method later. But we are going to do an example problem by using the table of values. So the first thing that we have to do is find the vertex of our graph. So we're going to be looking at this problem right here. Well, the vertex is again h comma k, and we have h right here and k right here. So we are going to look at those same spots on our function. We're going to look at this plus 3 and this minus 3. Well, if we look back at our general formula, we had a minus and a plus here. This x minus h happens when h is positive, and this plus k happens when k is positive. So if h is a plus h in our formula, we know that our x value of our vertex is going to be a negative number. A good rule of thumb is that if our operation between x and h is a plus sign, we know that h is going to be negative. Same deal here. So if we are looking at k, well, k was a plus sign. Plus k gave us a positive k. So if it's minus 1, we also know that k is going to be a negative. If a rule of thumb, or the rule of thumb is that if it is a negative or a minus sign in the k value, then it's going to be negative. So we have a negative 3 and a negative 1 as our vertex. So we know that our vertex is going to be negative 3 comma negative 1. Remember, in our absolute value graph, we have a graph that looks like a V. So if we drew the parent function of our absolute value graph, it would look something like this. Our vertex is our lowest point, is that midpoint of our absolute value graph. So when we are using a table of values, we're going to put our midpoint in the middle. So we're going to put our vertex in the middle of our graph. Now, when we are using a table of values, we have to find the graph when it is going towards the right side and going towards the left side. Well, we see that our absolute value graph here is symmetrical across the vertex. So we will have the same point for y when we move the same exact distance of x. To visualize this, or to help us plot points in that manner, we are going to move one step up from x and one step down from x. So we're going to add or subtract 1 from our vertex and add 1 from our vertex, right? Because we are looking to see points on the positive side and points on the negative side. So we're going to go towards the negative direction by subtracting 1 from our vertex, and we're going to go towards the positive section by adding 1 to our vertex. So we have now, by subtracting 1 from -3, we get -4, and by adding 1 to -3, we get -2. So now we want to find the y values of these specific x values. Remember, a function is practically a machine where x is an input and f of x, or y, is my output. So to do this, we are going to plug in our x values into our function, substituting x in to find our y values, just like how we did in Algebra 1. So we're going to do, if we started with our vertex, we can do f of -3 is equal to 2. And whenever we plug anything in, we are going to put parentheses around our number. So remember GEMDAS, we are going to do our grouping first. So we have to do everything inside our grouping. So we're going to do -3 plus 3, giving me 2 times the absolute value of 0 minus 1. Well, now we have to take, we're still in our grouping stage. We still have to take the absolute value of our 0. So we're going to take the absolute value of 0. Well, the absolute value of 0 is just 0. So we're going to get 2 times 0. And this is when I can drop the absolute value brackets after I take the absolute value of the inside. So now we get 2 times 0, which is 0, meaning we get 0 minus 1, giving us y equals -1. So we just affirmed or reaffirmed that when x is equal to -3, our y is going to equal to -1. Well, we already knew that based off of our vertex, based off finding our vertex, but it's a good way to check. So now we are going towards the negative side. Let's start with the negative side first. So we're going to plug in -4 into our equation. We get f of -4 is equal to 2 times, parentheses, -4 plus 3 minus 1. So we get 2 times the absolute value. Well, -4 plus 3 is -1 minus 1. And here's the important thing. We have to take the absolute value of -1 first. We have to do everything inside the grouping first. So we're going to do 2, and the absolute value of -1 is +1. Now we get 2. 2 times 1 is 2 minus 1, giving us f of -4, or y, is equal to 1. So we get a 1 here for our y. Now we are going to do the same for -2. So now instead of analyzing for the negative side, we're going to analyze for the positive side. We're going to f of -2 is equal to 2 times -2 plus 3 minus 1. I get 2. Everything inside the grouping, -2 plus 3 is 1. Absolute value of 1 is just 1. So we get 2 minus 1 again, and we get y is equal to 1. So when x is equal to -2, y is also equal to 1. Now there are 2 things I want you all to notice. when we are analyzing. One step below and one step above our vertex, our middle point, we have the same y values for both of these points. So when you move one step below and one step above, you get the same y values. Well, if we looked back at our graph right here, of our parent graph right here, we see that, of course, it's symmetrical across the vertex. It's a V. It's symmetrical across the vertex. So we are going to get these same points whenever we move one step down and one step up. Now, you can move 2 steps down and get a point, but that means you would also have to move 2 steps up. So moving 2 steps down, you can still get a point. And you can actually move 2 steps down if you really wanted to. But to make sure that we are graphing our absolute value equations and inequalities correctly, if you move 2 steps down, if you move 3 steps down, 4 steps down, however many steps down, you have to do the same going up. So that is just a rule of thumb. One other thing that I want you all to notice is that since they are going to be the same values, you know that if you are moving one step down and one step up, you should get the same y values. If you do not get the same y values, then you know that you either messed up doing the calculations or you messed up finding your vertex. So it should be a way for you to check them. Now, all we have to do now is plot these points. Our vertex, our point is -3, -1. Our negative side, we have -4, 1. And our positive side, we have -2, 1. So we are just going to move on our graph, starting at the origin. We're going to start with our vertex. We're going to go 1, 2, 3 to x equals 3. And then we're going to go 1 down, plotting our point at -3, 1. Next, we are going to do our negative side. We're going to go left 4, 1, 2, 3, 4 to get the x value of -4. And then we're going to move up 1. We're going to go boom, up 1, giving me the value -4, 1. Last but not least, we're going to do the positive side. We're going to move to the right or to the left 2 times. 1, 2 to get x equals -2. And to move up 1 again to get the y of 1, giving us the point -2, 1. All I'm asking for you all to do on a test or on a quiz is to plot 3 points at least. You need to plot at least your 3 coordinates. From there, you can just roughly sketch your graph. Now, we've emphasized that absolute values have to be positive. And in our parent graph, we see that our absolute value, this is a drawing of our parent graph once again. We see that our absolute value, all our outputs, all our y values are above the x-axis. But why in this graph are we going in the negative direction? Why do we have a point here underneath the x-axis? Well, to make a long story short, the reason why our absolute value graph is going into the negative direction is not because of our absolute value. It's not because of our absolute value. It is because of the integers or the slope and the y-intercept or the y of our vertex. These affect how our graph looks and how our graph transforms. If y'all remember back in geometry, transformations of graphs, our slope and our y-intercept And our horizontal shift, our vertical shift, will affect how our graph looks. We shifted left 3. From our origin, from our parent graph, we actually shifted left 3. And we shifted down 1. So you see that even though we have an absolute value problem, we still have outputs or variables that will go in the negative direction. That is perfectly fine. We have a function, which is an equation. It's not dictated by the absolute value. It's dictated by all the components of our graph. So now we're going to be talking about the second method of graphing an absolute value. This method is very niche to the absolute value. You will only be able to use this during the absolute value. So when you have an absolute value problem, you can use this as kind of a check. Or if we ask you or we tell you that you can use any method, you will be able to use this method as well. However, you will not be able to use this for other forms or other functions that are put into vertex form. Other functions that are put into vertex form will have to use the table methods by the table of values. But this special absolute value graphing method is by using the slope of our absolute value. So our first step is actually to find the vertex. Well, we first see that x minus h is a negative. It's a minus sign, it's not a plus sign. So we know that we're going to have a positive. We're going to have a positive 4. And we also see that it's going to be plus k, not minus k. It's plus 2. So we're going to have a positive 2 as our vertex. We have 4, 2 as our vertex. Now, using the slope method is very easy for our graphing. We are actually going to use our slope, our a. We said that a was our slope, and we're going to use this slope, 2 over 3, to graph the right side of our equation or of our graph. So to do this, we're going to plot the point 4, 2. We're going to go 1, 2, 3, 4, and then up to 1, 2, giving us this point right here. And now we are going to use our right side. We're going to use our slope to graph the right side of our absolute value graph. Well, remember that our slope is rise over run. So we're going to rise 2 from our vertex and run 3 from our vertex. So we're going to go 1, 2, and then 1, 2, 3, giving us a point right here. So we're going to go 1, 2, 1, 2, 3. And if we did one more point, we go 1, 2, 1, 2, 3 off the graph. Now, our slope only indicates our right-hand side or our right side slope. But our absolute value always looks like a V. So how do we graph the left side? Because if we were to graph in the opposite direction, usually we'd graph, if it was 2 over 3, we'd to graph the other side, we'd go down 2 and then left 3, right? But this would actually cause us to get a line. And we don't want a line, we want a V. So how do we get that V? How do we find the points accurately? Well, we should know that our absolute value graph is symmetrical across the vertex. So whatever happens on the right side needs to happen on the left side. You want to find the point that is adjacent to this point right here. You want to find the point that is adjacent to this point right here. So how do we do that? Well, we are going to keep the numerator the same. So we're going to keep the y's the same, but we are going to change the run in the negative direction. So we are going to go, instead of right, we are going to go left for our left-hand side. So we're going to go up 2. we're going to go 1, 2. But instead of going right, we're going to go 3 to the left. 1, 2, 3. Giving us a point right here at 4, comma 1. So we get up 2, left 3. We're going to go up 2 again, left 3. Up 2 again, left 3. And now we can draw our left side. Oops, I messed up one of my points. So technically, our graph should look something like this. So as you see, we have a perfect symmetrical graph. We went left 3, and we went right 3, and we went up 2, giving us the same exact distance between our vertex and these 2 points. So to recap, we are going to first graph the right side using our slope, using our A, and then we are going to flip it over to the left side using our knowledge that our absolute value graph should be symmetrical. So let's do the next problem. So we have a slope, first let's look at our vertex. Let's find our vertex first. Well, we have a plus h. Right here, we have x plus 1. So you know that we're going to have a negative x value. And we have nothing for k. Well, what is nothing? Nothing is not just no number. It is actually a plus 0. So actually our k, our y value is going to be 0. So we have a plus 1. So we're going to say that our x value for our vertex is minus 1, giving us a vertex of negative 1, comma 0. So now we are going to plot, or now we're going to find our slope. Well, our slope is a. We have a negative right here, and we are just going to bring that negative up to the top. We're always going to keep our negative to our top. So we're going to get negative 4 over 5. Just a rule of thumb, we are going to keep the negative always on the top number, never on the bottom number. Always in the numerator, never in the denominator. It also fits how we say it. We always say negative 4 over 5. Negative 4 divided by 5. We never say 4 divided by negative 5. So now we are going to plot our points. We're going to plot our vertex first. We're going to go to negative 1, 0. We're going to go left 1 to get that x value of negative 1. And we're going to stay there because our y value is 0. So we're already at y equals 0. So we're going to plot our point there. Now we are going to graph our right side. Remember again, it's going to be rise over run. So we're going to rise, or in this case, go down 4. We're going to go 1, 2, 3, 4. But our 5 is positive, so we're going to run to the right 5 times. 1, 2, 3, 4, 5. Giving us this point right here at 4, comma 4. If you wanted to do it again, we would go down 4 one more time. 1, 2, 3, 4. And we go right 5. 1, 2, 3, 4, 5. Giving us a point off the graph. Remember that our point or our graph has to be symmetrical across the vertex. So we are going to find the points that correlate with our slope. So remember that we're going to keep our top, but then we are going to change our bottom. So that means we are going to go down 4 and we're going to go left 5. So we're still going to go down 4. We're going to go 1, 2, 3, 4, and then we're going to go left 5. 1, 2, 3, 4, 5, giving us a point at -6, 4. If y'all wanted to do it one more time, we'd do 1, 2, 3, 4. 1, 2, 3, 4, 5, giving us a point off the graph. But now we have our absolute value graph that looks like this. Doesn't have to be exact or anything, as long as you show us the vertex and the right side slope, and you get the correct graph. So again, I'm only asking you all to plot 3 points, but please try to draw your arrows when you draw your absolute values, and try to extend it through your coordinate, past your coordinate even. All right, so that is it for 2C. Now we're going to move on to 2D, which is graphing absolute value inequalities. So graphing absolute value inequalities is the same exact thing as graphing absolute value equations. However, there are two kind of gimmicks, or there are two extra steps that you have to consider. So the first step of graphing absolute value inequalities is just to plot the points. So define the points of the functions and to plot the vertex and your two coordinates. Here I said to use the vertex and the slope, but there will be times where I ask you to use a table to find both coordinates. So it's not always going to you're not always going to use the vertex and the slope, but in our case we are just going to use it. But always do the table method as practice so that you get the hang of it. So we're going to plot the points of the functions from the vertex of our graph. So now, after we plot those points, we're going to graph our absolute value inequality. Now here is the first kind of gimmick. We are going to use a solid line if our inequality is equal to our function. So we have a greater than or equal to or a less than or equal to. So our graph is going to have a solid line if we have an equal to. So if we have a greater than or equal to or a less than or equal to. That means we are going to have a dotted line if it is not equal to. So if we have just a greater than or just a less than, no line underneath. After you graphed your absolute value graph, either using a solid or a dotted line, we have the extra step of shading. We have to shade above the graph if it is greater than or equal to. Oops, messed that up there. So if it's just greater than or equal to. So this could look like a graph that looks like this. If we had a graph that was facing up, we would shade inside our graph, or we'd shade above what our graph is hitting. We're going to shade above our graph, We're not going to shade in this area because this area is technically below our graph. So we are going to shade our blue. This could also look like this, where if our graph was facing towards the negative direction, well, it would be still above our graph. If we have a greater than sign, we're going to shade above our graph. And when we're shading, we're trying to say that all of the shaded region is or will satisfy our graph or our function. So shading our graph like this indicates to us that everything in the shaded area is a solution to our problem. It is a good. Everything that's not shaded is not included in our function. So if we shade above for greater than, we're going to shade below for less than. So below your graph, if it is less than or equal to. This, I'm going to write this on the right side, could look two ways. If I had a graph that was facing the positive direction, the upwards, well, it's going to be shaded below our graph, so we're going to shade everything below our graph. Because technically everything below these green lines right here is part of our solution. The second way that this could look, the second common way that this could look, is if our graph was in the negative direction or pointing towards the negative direction, pointing downwards, we could see our graph shaded inside the graph, but it's still below our graph. Everything above here, everything in this green right here, is technically above the graph, and these are not included when we have a less than or equal to. So green is a no-go. All right, so let's graph two inequalities to practice. First, we are going to find the vertex. Well, vertex again is h and k. So we have h comma k. And we have a k right here at +1, but we don't have an h. We just have x. There's no x minus anything. Well, technically, this is just x minus h, right? Well, that means it's x minus. If there's nothing there, it's going to be x minus 0, meaning our h is going to equal to 0. So our vertex is 0, comma, and since we have a +1, it's going to be +1. And our right slope, well, we don't have anything here. Here's a common mistake that some students make. If there's nothing there, but it's a multiplication, it's not 0. Because anything times 0 is 0. Well, the absolute value of x, if it was multiplied by 0, this would be 0. But it's still there. It's still the absolute value of x. So the mystery number, the number that is disappeared, that's invisible, is this 1. So we have a right side slope of 1. That means our left side slope is 1 over -1. Remember that we always change the bottom. We always put the negative of the bottom. We are just technically going left instead of right. Because remember, it's rise over run. So let's plot our vertex. We start from our origin. Well, if we didn't go anywhere in our x direction, we're going to stay on this y-axis. And we're going to move up 1 to find our vertex. Now we're going to use our right side slope to get our next points. Well, we're going to go up 1, right 1, up 1, right 1, all the way up. You don't have to draw this many points. I am just drawing these points to help solidify it. And we're going to do the same side on the left side. We're going to go up 1, but now instead of right, we're going to go left. So remember, all we're changing is the direction that we go, either right or left. So as you can see, you should see the same amount of distance between each of these points. You should see the same distance between this point, or between this point and this point, these points, to get this graph. So now we have to look back at our function. We have to look back to see how we are going to graph this function, because it's not an equal sign, it's an inequality. Well, we have a less than right here, and we have a less than, but not a less than or equal to. So if it's not equal to, we look back at our notes. If it's not equal to, we see that we are going to have a dotted line if it's not equal to. So we're going to go back to our graph, and we're going to graph using a dotted line. This dotted line means that all the points on this dotted line are actually not included in my solution. It would not work in our function. And if you just put in one of these dots into our function, you'll see that it actually does not work. So now we are going to look at our inequality to see whether or not we are going, or to see how we are going to shade. So we're going to look at our shading notes, and we're going to see that our less than or equal to, we have to shade below our graph. So we're going to look at our graph. We see that we have a less than sign, and we know that we're going to shade below. So that just looks like this right here. We're just going to shade below our graph. And that is practically it with graphing absolute value inequalities. So let's look at this second problem. If you feel like you have the hang of it, pause the video, try to see if you can get through it, and then unpause it and see how I work it through. So we're going to look for our vertex. We have H and we have K here. We have a minus sign right here, so we know that H is going to be positive. So we're going to have a positive 2. And we have a plus sign here for K, so we know that K is also going to be positive, giving us a plus 3 or a positive 3. Our right side slope is negative 4. So we have our negative 4 slope right here. We can also rewrite it as negative 4 over 1. That means we're going to go down 4 and right 1. So let's look at our vertex. Let's find our vertex first. We're going to go 1, 2. So we're going to go 1, 2 towards the right side. And then we're going to go up 3. 1, 2, 3, giving us a point right here. So let's plot that point down. Now we're going to use our right side slope to find the right side of our absolute value. We're going to go down 4, 1. We're going to go 1, 2, 3, 4, and we're going to go right 1, right here. We're going to do the same thing, 1, 2, 3, 4, and right 1. Now we're going to look on our left side. Remember that we want a graph that is symmetrical. So we're going to go just across the vertex. And we're going to do everything the same but instead of going to the right, we're going to go towards the left. So we're going to go 1, 2, 3, 4, but now we're going to go left 1. So let me rewrite that. It's going to be 1, 2, 3, 4, but now this left 1. So we have a point right here. And we're going to do it one more time. 1, 2, 3, 4. And we're going to go left 1. Now that we've plotted our points, we're going to look back at our inequality. We have this inequality right here. And we see that it is a greater than. So we have a greater than. But we don't have just a greater than. We have a greater than or equal to. So we know that our line is going to be solid. So we're going to draw a solid line through our points. Remember, the solid line means that these lines are included in my solution. These lines would be included and would work for our inequality function. Now, we look back at our absolute value, or not our absolute value. We're going to look back at our inequality, and we see again that it's a greater than. And we look back at our notes, and we see that if it is a greater than, then we're going to shade above. So we're going to take our graph, and we're just going to shade above. I'm going to use a different color. I'm going to shade above our graph. So some students say that less than you shade below, or some students say that if it's solid you shade below, if it's dotted you shade below, or something like that. No, it depends on our inequality, either our greater than or equal to. Or our greater than or our less than, my bad. All right. So now we are going to go towards the last part of 2D, figuring out the equation of our graph. So we're practically going to go backwards. I give you a graph, and I want you all to find the equation of it. The first step to doing this is to identify the vertex of our graph. Remember, our vertex is that midpoint. It's that lowest point on our graph. Then we want to identify the slope of the right side, because remember that A is not the slope for both sides. It's just for the right side slope. So the first step is just find H and K. And the second step is to find A. From here, if I were just to ask you to find the equation of our graph, you have enough information to put it back into our general formula. Remember, our general formula is f of x is equal to a times the absolute value of x minus h plus k. So if you did step 1 and 2, you have a, you have h, and you have k. So that means you're good. You're ready to write this equation down. But let's say I give you an inequality. I want you to find the equation of an inequality. That's where we move on to step 3 and step 4. We want to find we want to identify the inequality, meaning we want to find whether or not it's equal to or not equal to. So if it's a greater than or equal to, or less than or equal to. And once you find our inequality, you want to figure out how it's shaded, right? If it's shaded, if the graph is shaded above, then we definitely know it's going to be a greater than or equal to. If the graph is shaded below, then we definitely know it's going to be less than or equal to. So you want to identify the inequality, equal to or not equal to. This depends on solid or dotted. So this is solid if it's equal to, and dotted if it's not equal to. And the shading determines whether or not you get greater than or less than. So let's look at these two problems. We're going to first find the vertex. So we see that we have a midpoint, our graph. If we read left to right, we see our graph comes down, 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 hits this point right here, and it goes all the way back up. Well, now we know that that point is our vertex. That's our lowest point. Our lowest point, our vertex, is going to be at -3, 2. So now we have 1 point. Now I want to identify the slope of the right side. So that means I'm just going to look at the right side of our graph. Well, to identify the slope, remember that slope, A, is equal to, remember the slope formula, y2 minus y1 over x2 minus x1. That means I just have to find a second coordinate. All I'm going to do is look at this line right here. This line right here. And just find the nicest point. Well, I see that there might be a nice point right here at 3, 4. So now I'm going to use these two coordinates, this coordinate here, -3, 2, our vertex, and 3, 4 to find our slope. We're just going to plug it in. I'm going to make this x2, y2, x1, y1, and I'm just going to plug it into my formula. y2 is 4, so we have 4 minus, and y1 is 2, so 4 minus 2, over x2, which is 3, minus, and our x1 is -3, so 3 minus -3. 4 minus 2 gives me 2, and 3 minus -3, well, that becomes 3 plus 3, and this equals 2 over 6, which simplifies to 1/3. So now I have my A, I have my H, and I have my K. If I were to find a equation, then I would be done. But is this an equation? Well, you can clearly tell it's not an equation because you have a dotted line. Well, equations don't have dotted lines. Equations always have solid lines. But you also have the added benefit that it's shaded. You see it there, that our graph here is shaded. So now we have to take those two into account, those two features into account to determine what our inequality is. Well, we got to figure out whether or not it's a equal to or not equal to. That means whether or not it's dotted or solid. Well, since it's dotted, we know it's a not equal to, so we only have to look at greater than, or we only have to look at less than. So now to determine whether or not it's greater than or less than, well, we see that the graph is shaded above, or we see that we have shading above our graph, meaning that we are going to use a greater than. We are not going to use less than, excuse me. So now that I have all of my information, I can just write out my equation. I get y is greater than, not greater than equal to, just greater than, a, which we found as 1/3, times the absolute value of x minus -3 plus 2. Well, this minus -3 can be simplified to x plus 3, giving us the final answer of y is greater than 1/2 or 1/3 times x plus 3 plus 2, or times the absolute value of x plus 3 plus 2. So let's look at this last problem. We're going to find the vertex of our problem right here. I know the graph is a little wonky, but we're just going to say our vertex is right here. So our vertex is equal to -2, 0. Now we're going to look at our right side. We're going to look at our right side right here. And we're going to find a point on that graph. Well, there's a nice point at -1, 4. So we have -1, -4. And we have -2, 0. We're going to put this into our slope formula, y1 over y2. So we get a is equal to -4 minus 0 over -1 minus -2. This gives me -4 over -1 minus -2 gives me -1 plus 2, giving me -4 over 1. So now I have my A, I have my H, and I have my K. We know that now we're going to see whether or not it's going to be equation or inequality. So we have a solid line. So that could still be an equation, but we see that we still have shading right here. So we know that it's going to be a inequality. So shading right there. So we're going to figure out our inequality then. So we just stated that it's a solid line. So we can pick between two choices. We can pick between greater than or equal to or less than or equal to. Well, we see that our graph is shaded below, so we are actually going to choose our less than or equal to, because less than has shading below our graph. So now that we have all the information, we can write out our equation. So we get y is less than or equal to a, which was -4, times the absolute value of x minus -2 plus, and our k was 0. We can simplify this equation to be y is less than or equal to -4 times the absolute value of x plus 2. And then since it's plus 0, we do not have to write it down. So these are the notes for C and D. Watch through it again if you are having any problems. And I hope everyone has a great rest of your day.